Welcome back. Second recording of the day. Just finished our daily streak. Now we're gonna do the new class suggested by Ahmad, and he seemed to like it too. So I whip up a macOS VM in the past couple days. Slightly slow, but I think that's okay. I'm gonna do exercise with the phone first more. And another thing with it is that the resolution is still kind of weird. Gotta fix that. It doesn't take away the whole screen. It shows partially the screen. But with that, because I'm too cheap to buy a new computer, waiting for Thanksgiving, you can start the lectures. Just gonna watch it and do some commentaries and go from there. Recording, right? It's recording. This is Stanford. Which is developing apps for iOS.
Stanford University.
Hello, everyone, and welcome to
The quality
Stanford
is
University's
terrible.
CS193P. This is a course about developing applications for iOS devices like iPhones and iPads using a development environment called SwiftUI. This is a replay of this course. It was originally offered to my students at Stanford back in spring quarter of 2021. My name is Paul Hegarty. I've been teaching this course in one form or another at Stanford for about 10 years. And I know that all of you are coming to this with a very wide variety of backgrounds and experience and expectations for what you might get out of a course like this. So this time I decided to do this little intro for non-Stanford students to try and give you an idea of what to expect.
A little bit slow.
This quarter was another pandemic quarter, only offered remote, so you're going to be consuming this course in the same way as my students were on video, and there's definitely disadvantages to doing that. I love live lecture, can't do that, but there are advantages to watching on video.
That's
well.
why
For
I
example,
started my program.
that's a great feature to have when you're consuming very highly technical course content like you're going to find in this course. Of course, my students also had highly interactive class forums and the TA, and you're not going to have that, but there are a ton of really great resources out there on the internet. There's a very vibrant course is also intended not just to be a how-to course in iOS programming, but it's also a little bit of a how things work course. Systems design is really important for our CS students to learn.
System design,
huh?
huh?
More time in the lectures in this course, and talking a little bit about how SwiftUI is doing what it's doing, not just how to turn the knobs to make it go. So you'll see that flavor kind of sprinkled all throughout the lectures. A little bit about the prerequisites in this course. For the students who here at Stanford, they have the prerequisite to take at least 3 and recommended 4 intro CS courses. So they're relatively experienced programmers. One of the things in particular that students all know by the time they're taking
I did
is object-oriented programming.
5 maybe.
Even though we don't actually use much object-oriented programming doing SwiftUI, the concepts that you learn in object-oriented programming, like instances of data structures and encapsulation, these are really good things to know when you're trying to understand how SwiftUI works. Also, SwiftUI requires you to learn a new language called Swift, and for all of my students, they'll have learned a new language 3 or 4 times before coming in here, so it's kind of old hat for them to learn a new language. So if for you, Swift is going to be your second language ever, or you're a first-time coder and it's your first language, that is going to add a significant extra challenge to absorbing all the material in this course. So as you can probably gather from all that, this course is not aimed at the first-time programmer. I will say, though, that if you are just starting out coding, or even if you're not even a coder at all, maybe yet, you might still find the first couple of weeks of this course very interesting to watch, just to see what it's like to develop an application for iOS, because we dive right in. Students at Stanford haven't learned Swift yet, so we don't really assume that they know anything at the start. We're going to go step by step. We encourage the students to follow along. The homework really requires them to follow along. And so you should be able to do the same thing, really no matter what your level of programming experience is, at least for that first few lectures. And then you can decide kind of where you want to go from there. So hopefully that gives you all the information you need to know to get started. So off we go. So let's start by
the first 3 languages learned by students in Stanford are Python, C++, and C, and then assembly, if you count that one.
Looking at what we're going to build, and we're going to do that in these iPhone simulators. Okay? These 2 things you see on screen are simulating an iPhone 11 on the left right here and an iPhone 8 on the right. And when we run our application to see if it's doing what we want, of course we could plug our iOS device, our iPhone or iPad, into our Mac and run it on there. But a lot of times it's just nicer to be able to just simulate a device and see it right on our screen. And that's what these simulators allow. And they simulate not just our application running on an iPhone, but most of the iPhone environment as well, like the Settings app. We can go to the Settings app and set things that might affect the way our app runs, or contacts where you need to access the address book, calendar, etc. All these things that our application might want to interact with are also simulated on the iPhone.
There's a funny trick with you can kind of use this to simulate, use the browser. Forgot to do it. Inspect. Yeah, you can change it to the phone, and you can view it here. It's kind of like an emulator in itself.
Here's our app that we're going to build this quarter. It's called Memorize. It has no app icon yet. Well, hopefully we'll get to that during the quarter. And I'm just going to tap on it to run it. And here it is. And it's a game. I'm going to click here, this Halloween version of it. It's a card matching game. Some people would call this game concentration, perhaps, or memory, it's sometimes called. We're going to call ours Memorize. That's going to be the name of our app. And it's a very simple card matching game. You click on cards and they flip over, and you're just trying to match them. Okay, so these cards have emoji on them, and our Halloween has a nice orange theme to it. Those two cards don't match, so I have to keep searching around. Oh, I think that was this one, right? So now I can find a match. There it is. Get a little animation, spinning animation there. Notice also that there's this timer ticking down in the background. That timer is essentially saying how long this card has ever been face up. And so we clearly want to reduce that as much as possible and match these cards as quickly as you can. Now, notice there's no score on the screen because I'm leaving that to you. One of your homework assignments is to decide how to allocate points based on this timer ticking down and how quickly matches are made, or maybe penalize when you could have made a match, but you didn't, right? You know, there were two cards that matched and you're like, oh, oops, I didn't match that one. Oh no, that was the same as that one, etc. So you might be losing a lot of points here. Clicking around trying to find matches, or you might be gaining points because you're so good at memorizing that you're like, oh yeah, I know exactly where this thing was. It was right there, and I'm gonna click it and I match, and the timer doesn't tick down, etc. So I'm gonna leave that all to you. I don't want to bias you with any particular canonical implementation of the scoring, so that's totally up to you. This UI can do other things. We can create a new game, just restart, all the cards face down, reshuffle everything all around. You see there's a lot of animation in this game. Animation, very easy to do in SwiftUI. And back here, this part of the UI that we saw over here, not only lets us choose a different theme, so we had Halloween, let's pick vehicles. Now we're matching vehicle emojis. Okay, that we had a match there. Oh, there's another match. But it also lets you edit these themes. So I can go here and hit edit, and then I can click on these, and it brings up this nice UI for adding emojis to my theme, changing the theme's color, maybe
This
changing how many
Swift
pairs
does add a
of
lot of
matching cards, what its theme's name. You're going to be
bounties.
doing all of this UI, 100% of it, in your homework. Okay,
The
so by the time
animations
we're
are
done with
quite
this, just a few weeks from
nasty
now, you're going to have the skill to be able to
if
build
you do it
UIs
from
that look as
scratch. I
good as all
think.
this. Now, this is obviously a fair amount of UI to build. We're not going to build this all just this week, okay, in the lecture time we have left. So we're going to get ourselves started by just building some of it, a little bit of it. And so in this simulator, I have a version of Memorize right here that is going to be what we're going to build in today's lectures, or this week's lectures. And you can see it has the cards, and I can tap on them, and they do flip over, although they don't animate, and obviously there's no timer there. Also, if I flip over all the cards, you'll notice that no two cards are the same. So these are all 12 completely different cards. So we can't play the matching game because we have no matching cards. And in general, the whole logic of playing the matching game, we're going to do that next week. So what we're doing this week is just trying to start building our UI and have it look like this. Now, obviously, we're not doing any of this sophisticated UI over there. We're just trying to get our cards up here. We are going to put a couple of things down here that aren't in our final version, like this plus button, which adds a card, adds more cards. And also, our UI is going to scroll because we can hit so many pluses here that the cards don't fit anymore. Okay, whereas over here, that's not true. By the way, that's really noticeable. If we take this and rotate it, this button here will rotate to landscape mode, and the cards kind of resize themselves a little bit so that they fit the space more perfectly. In our version, when we rotate, it still works, but we have to be scrolling because we can't fit all the cards. So our cards are kind of a fixed size right here. I was originally going to have you do a shuffle button down here in your homework. It would shuffle the cards around, but I actually decided to have you do something a little more ambitious, which is to shuffle the cards, but also provide a very, very simple theme chooser. Now, nothing like the theme chooser we saw on the left here, but just something that lets you use what we're learning this week. Also, you probably noticed that shuffle is doing a little bit of animation, but I decided to put that off now as well, so you won't have to do animation for the shuffle buttons in your homework, and we're going to talk all about animation in a couple of weeks. So the tool we use to build all this is called Xcode. It is one-stop shopping for doing all of this stuff, whether it's editing your code, running it, seeing the UI as you build it, debugging it, etc.
I'm
All
not
in one place.
gonna
So let's talk
follow
briefly here about
along.
how we get a hold of an Xcode. Okay, we need Xcode. And since it's a Mac app, of course, we can go to the Mac App Store. If you go to the Mac App Store and go to the search bar and just type in Xcode, then you'll get the top match here will be this Xcode. And if you click on it, this is going to say download. Just click on that, and you're up and running. It's a free app, costs nothing. And you can join a developer program with Apple at $99 a year. And I'll talk about in a moment what you get for that, but it's not required. Not required for this class. Nothing that you do in this class, this app that we're building over here, none of that requires any developer joining the developer program at Apple, so it's free. So everything's free. Now, if you're a little bit bold and adventuresome and you want to try the beta version of Xcode, which of course they're always coming out with betas every few weeks, you're certainly welcome to do that. I'll show you briefly how to do that. Just bring up your Safari, go to developer.apple.com, And in fact, we can go directly developer.apple.com/downloads, probably the fastest way to get there. And you can see there's beta software downloads, both of macOS and iOS, but also under applications here, you're going to see Xcode 12.5 beta 3. And this is, again, going to update over time. You just click download and you can run it. Now, nothing I do in this course is going to require this beta, so you're perfectly fine if you just want to do the version off the App Store. Maybe start off with that one. And as you get more confident and you just want to kind of be on the bleeding edge of things, feel free to switch over to the beta if you want. Once we get Xcode on our machine, we launch it just by clicking on it. I happen to be running the beta version here. And when we do, we get this splash screen. Okay, beta or normal, you're always going to get this splash screen. Very simple starting point in Xcode. On the right over here, we have all of our recent projects, things we've been working on will be stored here. And then on the left, we just have 3 options for starting a new project or finding an existing project that's not in this list, which is pretty rare. All the projects we work on are kept in here reliably. So this is usually how we open that. There's 2 ways really to create a brand new project. One is to just create it here. That's what this first one is. The second one is to clone a project that is in a source code repository somewhere. I am going to talk a little bit about source code control and repositories later in the quarter, but for now, we're just going to obviously be creating our very first project ever by clicking this create a new project. This open a project or file down here, not going to really have to do that. Those things will all be over here. All right, so click create a new Xcode project. It immediately says, okay, well, what kind of project do you want to create? Because Xcode can build not only
none
iOS
of
apps, which is
this.
what we're clearly building here, but also macOS apps, Apple Watch apps, Apple TV apps, even multi-platform apps that run both on macOS and on iOS. And we will be doing that for the second big app that we build later in the quarter. But today we're going to do iOS apps. Even within iOS, there are different kinds of apps here. And most of the time, we're going to do this just basic app. But later in the quarter, we're going to make a document app. And there are other kinds here. So you might explore some of these for your final project or whatever. But we're going to do iOS app. Just click here and here. Make sure you do that when you're building your app. By the way, here's where you might want to pause and go get Xcode if you want to follow along. If you do, be sure to click iOS and then app.
My stream will crash.
Next. Now, when you do that, it's going to ask you some questions about this iOS app you want to build. First question, well, what do you want to call this thing? Well, we know that we're calling our app Memorize. The second thing here is the team. This is the development team working on this. Well, that's going to be you. Now, when you run this, unless you've used Xcode before, this probably says something like create a team or something. And you're going to click on that to create a development team. And it's really easy to create a development team. You just need an Apple ID. So that's just your normal iCloud login or whatever. Again, it's not going to cost any money. You're just going to go and register this development team with that iCloud Apple ID. And that's it. And you'll be off and running. Next, you're going to have a string, this organization identifier. You are the organization, basically the organization you work for, but you're a student. If you're not a Stanford student, this might be the company you're working for, whatever. But it just has to identify your organization that you're working on this. If you're an individual, I really recommend using what this is called reverse DNS notation right here. Maybe your email address, or if you're a Stanford student, edu.stanford.cs193p. Your SUNet ID right here instead of instructor. Maybe you can even skip the CS193p if you want. But you just want to pick something here that no one else is going to pick. Okay? And if you're for a company, this might be your company's website name backwards or something like that, or even your company's website name backwards and then the group you're in at the company or whatever. So this just has to be a unique thing that identifies the group that's working on this app. So Xcode quickly combines the name with that to create this bundle identifier. That's a unique ID for this app. Makes perfect sense. Now, these last 3 little choice boxes here are kind of letting you choose between the new way, SwiftUI, of developing iOS apps and the old way, which is called storyboard right here. I only have 10 weeks to show you this stuff, so I can't show you both. The new way, it's very new, only introduced about 2 years ago, but it's very powerful, and it's also kind of benefited from all the learning that the old way had. So when you're creating an app, you're always going to have these 3 buttons be on. SwiftUI, the new way. SwiftUI app, that's the new way also. You can mix the new way with the old way of creating an app. It's kind of odd, but you can do it, but we're not going to, so we're always going to do SwiftUI app. And since we picked these, the language, there's only one choice, which is Swift. SwiftUI is totally dependent on the Swift language, which is a new programming language that I'm going to not assume that you know, and I'll be showing you that language from scratch the entire quarter. If we had picked the old way up here, then we would have another language choice here called Objective-C. That was the language that the old way was originally written in. But again, it's all Swift all the time in this course, so we're always going to have these buttons in these Swift settings here. The last thing, these switches down here, make sure they're all off for this first app, but we are later going to look at this core data thing. That's an object-oriented database. Probably not going to have time to show you the testing framework in SwiftUI, but it's pretty darn amazing. It lets you test not just the back-end code, but also even your UI to make sure that your UI is looking like it's supposed to. But again, please, all of these off for the first version here, Memorize. We're going to hit next. Now it just wants to know where you're going to put this thing in your file system. I strongly recommend putting it in your home directory in a folder called Developer. So all of your projects should be collecting over here in your home directory, Developer. This is the canonical place to put it. You can see that the Finder here even puts a hammer icon on there. It recognizes this is a standard kind of folder. Down here, we have the source control. That's what I was talking about at the beginning, where you're storing this stuff in repositories. And this is something we will talk about later in the quarter briefly. Source control is good as an individual for versioning your app as you work on it, but it's really valuable for teams. When you're working on a project with teams, 5 programmers or something working on one app, or even 100 programs working on one app, how do you not step on each other? And this whole source control thing provides a mechanism for checking out your code, making changes, checking it back in, making sure it doesn't conflict with what other programmers on your team have done, etc. Again, we'll briefly talk about this later in the quarter, but we definitely want this off to start. I say definitely, but I'm going to do it with it off. So if you're following along, things might look slightly different if you have it on. So let's leave that off. and hit create, and voila, it created our app for us. This is our first iOS app. Congratulations, you built your first iOS app. This is the main screen of Xcode. You're going to spend all quarter long living here, so I'm going to spend some time talking about all the parts of this. And I'm going to start right up here at the top with this fun little combo of buttons. This is how you run your application. So the first thing you do is pick where you want to run your application. That's this. Right now it says iPod Touch 7th generation. That's where it would run it if I ran it, but I'm going to click on that, and you can see that I can choose to run it on an iOS device connected to my Mac. I don't have any connected right now. Or I can run it in one of those great simulators that we saw. Right? There's the iPhone 8 simulator, iPhone 11. We're going to run our app on the iPhone 12 mini, my favorite iPhone. And you just select where you want to run it, and you just press this play button. And then when you're done, you press stop. So play and stop. So let's go ahead and hit play, and it's going to launch this iPhone 12 mini simulator. There it is. And it's going to install our app on it, and it's going to run the app. And there it is. It just says hello world. Now, those of you who were looking back here at our code probably saw that hello world right there, and you're like, I bet this app says hello world. And in fact, it does say hello world. That's what this app says. And otherwise, it's just big blank space. And that's
Is
cool.
there
We can
going to
do
be
that.
like
And we can do things like
drop-in?
rotate, and it's
We
nice
can
and clean,
drop
keeps it automatically
things,
centered. And we're going to find that
or
this
we have to type
thing where we
everything.
rotate and our UI changes, we have to do very little code for that. SwiftUI pretty much handles that for us, centering things properly and all that. So then when we're done simulating our app running right here, and again, this is a full iPhone simulator. I can switch over and run settings over here or whatever, and go back, switch back to my app, full simulation there. So when we're done, we press stop, it stops running. I have the menus kind of hidden just to give us more space, but obviously there's a lot of menus up here in Xcode, and we will be using them. And obviously as the quarter goes along, you'll be learning them as we go. It can be intimidating to see so many menu items with so many things, but again, we'll slowly unveil them. It won't be quite so intimidating as all that. There's a little status window here that just tells you what's going on here. We just finished running Memorize, right? It'll say when it's compiling and all those things. Let's take a look at this blue area here on the left. This is called the Navigator, and it does what it says. It lets you navigate your application. It lets you navigate it in lots of different ways. These little icons up here are letting you choose those different ways to navigate it. And the default here is to navigate it by file. These are all the files that are in our application. These 4 files were created for us by Xcode to get us started. And I'm going to actually look at all 4 of those in a moment here. But we can also navigate other ways by searching throughout our project, or if we're debugging, we can look at all of our breakpoints, etc. We'll see these different ways of navigating as we go. All of the parts here can be resized. Okay, just grab this with your mouse and you can make things bigger or smaller to allocate the space as you want. You can also hide and show with this little button. A lot of times, once you're deep into doing some editing, you really don't need to switch back and forth between files here, especially because you're going to see tabs developing along the top here, like this thing that says Contentview.Swift, where the files that you recently edited are in tabs. So then you really don't need this as much unless you're going to search or something like that. Now on the right, this area here, this gray thing is called the inspector. I'm going to show you that a little bit later. In the center, this 2-paned thing here is the main editing window. Usually you're going to have your code here on the left, and then you're going to have one or even more of these other ancillary windows. This particular little space right here is very cool. This is the previewer. The previewer previews your UI. It actually shows you what your UI looks like without having to run it on the simulator. And it shows it to you mostly in real time. Now it does pause occasionally. It says right here, automatic preview updating pause. That's why we're not seeing our hello world code over here show up. But we can resume it at any time with resume. And when we resume, it essentially is like launching a little simulator in place right here. And we can zoom out a little bit. And we see our UI. There's our little hello world UI. And yes, we can divide the space up better if we want. We're going to see this preview used all as we're doing development. It's just all kind of always going to be previewing for us. It's a really powerful, really awesome system. Up here at the top, we also see there's a little line that's just saying where we are, specifically where our cursor is. So if I click down here, it's actually saying we're in this body thing. If I click down here, see it's saying we're in this content previews thing, whatever that is. You can even click on this and navigate around, jump your cursor around, jump it down to the bottom, jump it back up to the top, etc. So this is kind of where our cursor is up here. Now, one thing that's cool about these 3 things here, the preview, our main code editing, and this inspector, is they'll stay in sync. If I click on this line of code right here, it not only selects this thing that says text hello world, but it selected that hello world text thing with a blue line here, and it made an inspector, some kind of UI over here for inspecting or editing the attributes of this thing I have selected. And if I click away, then it stops selecting here. Nothing is being inspected. Click back, it's doing it. If I click away, I can also double click in here and it'll select it here, show me here, and select it over here. These things are linked. They're always showing you, unless this thing is paused, they're always showing you what's in the other of the 3 panes. And we can edit things or change things in any of these panes. For example, we have hello world here. What if we said hello CS193P? Look at that. It changed here and it changed up here. And we could change it up here. We could say hello there, CS193P, changed it here, changed it here. What was really cool is as I was editing it here, it was changing in here in real time. And it will always do that as long as it's not paused. If it gets paused, then you're just going to hit resume and it'll continue. This inspector over here is pretty powerful. It's not just changing the text You can also change the font color, etc. Here I even have some padding. You see this little blue
Almost
dot says that my padding is on, and sure enough, you see this says padding right here. We're going to look at all this code in a bit here,
adding those
but this little padding in
Excel
here,
or
if I turn this off, it takes that out of there. Or if I turn it back on, but only for vertical padding, then I
it's like PowerPoint code onto it.
use padding vertical. Right? Again, we're not worried about what all this means, but the point is that as we change things over here, it's changing them over there. That is your tour of Xcode. There is the debugger, which comes up from the bottom. We'll see that a little bit when we start doing some debugging. You won't need to be using the debugger during this first week's lectures. And the stuff I'm going to ask you to do the homework is very straightforward and will not require debugging. Let's go back and do what I said and look at these 4 files that Xcode created for us when we created this project. We'll start with this one, assets.xc assets. When it says assets, it means things like images and sounds and videos, those kinds of assets. What we do for that when we're building an iOS app is we drag the assets into here and we give them names. And so in the white column here is going to be the names of the assets, and then here is going to be the actual assets themselves. So you will see the images showing up right here. Now, some assets are more complicated than the others, like your app icon is quite a complicated asset because it has lots of different resolutions. These resolutions here are dependent on the environment, whether it's on an iPad or an iPhone, or you in the spotlight area, is it a notification that just came in on your iPhone for that app, whatever. And if you have an app, especially an app that you're shipping to the App Store, you're probably going to have an artist or somebody make some perfect, nice icons that look good at all of these resolutions. We're not going to look at the assets more than this, but we will be using it later when we want to add images or whatever to our application. Right, what about this thing, info.plist? This is essentially settings of your app. But this is a pretty raw way to edit it, and we usually don't edit this info.plist directly. Instead, if we go up to our project and click on the project itself, we get a nice UI for editing these same settings right here. And what kind of settings are we talking about? Well, maybe does this app run on an iPhone? Yes. iPad? Yes. Does it run on the Mac? No. We're not building this Memorize app to run on the Mac. The next app that we do, we will have it run on the Mac. Also, are we deploying to iOS 14, iOS 13, iOS 11? Obviously, the farther back we try to deploy, the fewer new features we get to use, etc. So all of this stuff, when you change them here in this nice UI with switches and all that, just changes it in this list over here as well. We don't really look at our info.plist hardly at all. We're almost always clicking up here if we want to change project settings. And 99% of the time, you don't need to change any of these settings. They just default to the right thing. That leaves us with these 2 files right here. They're both .swift files, Swift language files. The Swift is a new language that I'm going to be showing you from scratch. This one right here, memorize app.swift, I'm not going to look too closely at that one. It really doesn't matter too much. A couple of things to note about it. It's our main program. In C, you have like main.c, which is the main C module where your app, when it runs, starts executing. We have the same thing in Swift, and this is it. Because we put this @main in here, this becomes our main program. We don't worry too much about all this. The main thing to note here is that this content view that's in the middle is basically saying that this other Swift file, contentview.swift, is the thing that describes what our app looks like. So when we go
First to whip up the VM.
to our simulator over here and see our app, this whole area right here.
I just want to know how I did this VM. Yeah, I could make a video too. I actually learned it from another video.
Here, no matter which app we're talking about, is our contentview.swift. That's really all the main program is saying, is what is the name of that main area. And that's this, contentview.swift. So this code is the entirety of the code that makes this. In fact, it's a little bit more than the entirety of the code. It's also got this little thing at the bottom, content view previews. This is the code that glues this previewer to our content view. So really only this is the entirety of the code that draws our hello world. And this glue code, we hardly ever even touch this. I'll show you a little bit later this week's lecture how we could modify this a little bit, but most of the time we don't pay any attention. In fact, I usually like to just get it out of my way, so I don't even see it. It's down there, it's doing the glue, but I don't even look at it. Notice, by the way, that when I made a big change like that, our previewer paused. So I can hit resume, and it'll continue. Okay, that is it. That is your tour of Xcode. So now we're going to focus in on these lines of code and understand what every line of code in here does. I'm going to reset this hello CS193P to hello world, hide that, and focus in on
Yes, this is the output.
that content view right there. Move that a little bit out of the way. So let's just go through this line by line. This top line, import SwiftUI. This one's an easy one. This is like include or import that's in other languages. We're basically just saying that this file is going to use the package Swift code called SwiftUI. Now that's made by Apple and it ships with all iOS devices and on macOS and Apple Watch and all these things. And it's here because we're doing UI in this file. but not every file that we create is going to have UI. For example, the files that we create that do the logic of our game, that actually match cards and keep score, that is not UI. That is logic, and that will not be importing SwiftUI. And one of the great things about SwiftUI is how it clearly separates that logic from the UI. But here, we're working on UI. We're not even going to start doing our game logic until next week, so this is all UI. So of course, we want to import this SwiftUI here. This is the entirety of our code that generates the UI, and it's creating a data structure here. So struct, kind of short for data structure, and most languages have structs. Structs are essentially collections of variables, and you can see has this, and pretty much all languages they may not call it struct, but they have some sort of collections of variables. Swift's collection of variables is pretty powerful because not only can we have variables in our struct right here, in fact, here's a variable we're going to look at later, but we can also have functions. So, func foo, whatever, has some code in there. This is perfectly legal. We will be looking at functions, especially next week, but we actually don't need much in the way of functions to build this UI, it turns out, but structs can have functions on them. And that might feel to a lot of you like object-oriented programming, because object-oriented programming is some data, variables, encapsulated together with the functionality on it, what we call methods in object-oriented.
Funny because I think the creator of object-oriented programming defines it as a program that can send message and receive message. That's object-oriented, not like this property and function. Yes.
Programming. And Swift does actually support object-oriented programming, and we will even be using object-oriented programming, especially to connect our logic to our UI. You'll see that next week. However, nothing that you see this week is object-oriented programming. Structs, in particular, even though they can have variables and functions on them, are not object-oriented things. They're not classes. There's no inheritance or anything like that. And structs have different things, I'm just about to talk about, that lead to a kind of program that we call functional programming. Swift supports both object-oriented programming and functional programming, and we use the functional programming design model in the UI code that we built. We use the object-oriented design model to hook up our model, our kind of logic, to our UI. So today, all the things we're talking about, functional programming. All right, we clearly don't need this function foo, doesn't do anything anyway. What's the next thing after struct? Struct is a keyword. All our keywords, of course, in magenta here, easy to understand that. Next word is Contentview. That is just the name of this data structure, and this can be any name we want. This is our app we just created. It says hello world. It didn't really know we were going to build a memorize app, so it called this thing Contentview because it's essentially the contents of our entire app. And I'm going to leave it to that, but down the road, we're probably going to rename this to something like Memorize View or something a little more specific to what we do. But it's just the name of this structure, nothing special about it. This is very special. Okay. This little colon view, when you're defining a struct, means that this struct that we're creating behaves like a view. And I told you this is functional programming.
Output.
In functional programming, the behavior of things, how things behave, is crucial. Now, most of how a thing behaves is the functions that you can call on it that defines how it behaves. But even the storage, the data storage, functional programming says nothing about how data is actually stored. It can talk a little bit about what data there is and what data should be in this struct, but it doesn't say how it should be stored, whether it's stored in memory or calculated or whatever. So in that way, it's very different from object-oriented programming because you're not encapsulating the storage with the methods on that storage, the functionality. You're just talking about the functionality and describing the storage that might exist. You're not actually implementing it. When you say that you have a data structure that behaves like something, in this case, behaves like a view, and we'll talk about what that view is in a minute here, it's really a double-edged sword there. One side of the sword is really great, which is that a view has a lot of functionality that's built into the SwiftUI library. And so as soon as you say you behave like a view, you get all that functionality because views do all those things and you behave like one, so that's great. But the other side, the other edge of the sword, is that you might have some responsibilities if you want to behave like a view. You can't just walk down the street and say, yeah, I behave like a view. Sometimes behaving like a view means you got to do some stuff too. And in fact, behaving like a view, even though it's hugely powerful, really only requires you to do one thing, which is to have this variable. We're going to look at that variable and what that means in just a moment. But first, let's talk about what a view is. When we say that this data structure we're creating behaves like a view, what does that mean? Well, a view is just a rectangular area on screen. And this struct, content view, is this rectangular area. Now, the corners are rounded here just because the device is rounding them off. This large rectangular area is this view, content view. And a view has the capability to display things inside. Here we see it's displaying some text. That's good. And it also can receive input from the user in the form of multi-touch events, taps, swipe, pinch, things like that. That's all a view is, really. It's just a way input and output in a rectangular area on
That
screen.
might increase the app size.
That's simple in concept, but in implementation, it's super powerful because we want to build very beautiful rectangular areas on screen, like, for example, this, where things are flipping over. Now, in this sort of view right here, we have this content view or this top-level view. But there's also a view here, which is this text. This card is a view that's got multiple things on there. It's got this emoji. It's got this kind of rounded rect drawing around it. And if we go look at a complicated thing here, we got all kinds of views in here. That text, this smaller text, there's even this little arrow right here. The whole thing where we can click on something and it goes to another view. Those are all view. Everything here, everything on screen, every rectangular area is a view. And you can see that some views, like these cards, are embedded in larger views, right? Views inside views. And this is kind of obvious. Almost every UI system has this idea that there's rectangular areas on screen and you combine them to make your UI. But in Swift, we do it with this functional programming model, and we say that we're building this content view that behaves like a view. What can a view do? A ton of things. We actually earlier saw something a view can do, which it can be padded. When we had this text here before, it had this little padding turned on and it got a little bigger, a little space around it. That's just one tiny thing. Look at all these other things up here. Those are all things that views can do, set their color and all these things. And we're going to see all of this and how we leverage the power of the behavior of a view a little bit later. But first, I'm going to look at the flip side of view, which is this requirement that if we want to behave like a view, we have to implement this variable. So this is a great opportunity to talk about variables inside of a struct, inside of a data structure in Swift. This is what it looks like to declare a variable. Super simple. Keyword var for variable. Body is just the name of that variable. And then colon sum view, that's different than this one up here. Colon sum view is the type of that variable. Now, this is a pretty complicated, not necessarily complicated, but an important kind of type.
The
It's a little bit
sum
odd.
for.
Normally, the types would be very straightforward, like var I is an int, okay, or var s is a string. That's what most variables look like in Swift. This one has this weird sum keyword in there, the sum magenta keyword, and also it's got this view thing, which we know that a view is a behavioral thing. So why is the type of this body variable sum view behavioral thing? Well, it's kind of exactly how it reads. The type of this body is something that behaves like a view. That's what the type of this var body is. Let's think about that. That's kind of strange. To create a data structure that behaves like a view, you are required to provide a variable whose type is some other thing that behaves like a view. That's kind of strange. Here's an analogy that might make it make sense why the requirement to behave like a view is that you have to have a variable that provides some other thing that behaves like a view. And that analogy is Lego. Hopefully all of you have had the joy of playing with Legos in your life. Legos are little blocks, little building blocks you use to build really cool things from, little tiny house, Lego house. You could build the Lego Star Wars Super Star Destroyer, okay, and everywhere in between. So Legos are very powerful little building tools. And if you think of views as being kind of like Lego, the analogy, it's not perfect, but it kind of works. Let's think about a Lego. Let's say I wanted to build a Lego house. Okay, a Lego house has got all the rooms in it. It's got a kitchen, it's got the bedrooms, it's got bathrooms. Let's say it's got a dining room. And in each one of those, there's a lot of other little sub-Legos in there. Like the kitchen's got a bunch of kitchen cabinets and table and appliances. The dining room has a dining room table and dining room chairs. And so you can see that the Lego house, we're actually building out of other Lego. Now, we can think of that Lego house as just 1,000 pieces of Lego. But actually, when we really build something like a Lego house, when we're building, let's say, the dining room, we build the little dining room table out of some Lego, and then we build one dining room chair out of the Lego. Then we're going to build another dining room chair, exactly the same. We might have, 8 dining room chairs around our dining room table, and they're all exactly the same, those dining room chairs. So if we think of the dining room chair itself as a Lego, yes, it's a Lego we built out of other Legos by stacking them on top of each other and connecting them up. But once we've done that, it's essentially become a dining room chair Lego. And then we can take 8 of those and combine them with the dining room table Lego, and now we essentially have a dining room set Lego. And then maybe combine that with the rest of the furniture in the dining room, we have a dining room Lego. And then we put the dining room Lego together with the kitchen Lego and the bedroom Lego, the bathroom Lego, put them all together. Now we have a house Lego. And we can put that whole huge house Lego together with other house Legos to make a Lego neighborhood and Lego planet, the Lego universe. We could build an entire universe out of Lego. So if you think of it that way, you make just the simple kind of leap to say that a Lego dining room chair is itself a Lego, built out of a Lego, then that's how views are created. And so that's why it makes perfect sense that if you're going to behave like a view, that you have to provide this body variable that is some other view, right? Because we're going to be building Legos out of Legos, as simple as that. Now, to understand our analogy a little bit better, let's talk a little bit about the kinds of views that you're going to find in SwiftUI. Of course, you're going to find this kind of view, text, which is like a Lego brick. A basic building block, stands on its own. If we look in our UI, they are everywhere, here and here and here. On the card, this emoji is just a string, a little text. So that's one clear kind of view. Similarly, we have these shapes like rounded rectangle and circle and oval and things like that. These basic shapes, those are Lego bricks as well. But the real powerful views that we're going to find in SwiftUI are the combiners, the Lego combiners. And they're the things that take these other views and combine them on screen, either arrange them in a grid like this perhaps, or maybe in just a line across, stack them on top of each other, things like that. Those kind of combiner views are probably the most important thing to making complicated user interfaces in this Lego model of piecing things together. There is one other kind of view that I'm going to talk about, which is like, if you want to use our Lego analogy, it's a bag of Lego. If you buy a very large Lego set that has thousands of pieces, let's say Star Wars Millennium Falcon or something, when you open the box, the people at Lego have very kindly grouped a lot of those thousands of pieces into little clear plastic bags so that when you get to the part of the Millennium Falcon, let's say the gun turret on the bottom or something, you don't have to search through thousands of pieces to find the pieces to build that. There's a bag, that's the gun turret bag, and you open it up and there's only a couple hundred pieces in there to build that part. And so you don't build your Lego Millennium Falcon by just throwing the bag on top of it or sticking the bag in there somewhere. You open the bag and combine the Legos. So those last two kinds of views I talked about, the combiners and the bag of Lego, they go together. A combiner is obviously going to take a bag of Lego and open up and put it together. And armed with that knowledge of the different kinds of views, you're going to see that this var body is almost always going to be a combiner view. In our case, right now, it's just a single Lego brick, this text, but this sum view is going to be a view that is a combiner view most of the time, the vast majority of the time. We'll get back to this sum view syntax and what that really means in a second. But first I want to talk about this little piece of code right here. What is this? This just kind of plopped in here right after this var body sum view. Well, this is actually a function. And I told you that Swift is a functional programming language. And in functional programming language, functions are really, really important. In fact, functions are first-class citizens, and we can drop functions anywhere we want. Now, this is something that for some of you, maybe even programming in Java or languages like that, having functions be things that just plopped right in the middle of your code might be slightly jarring. But you're going to want to get used to it because in a functional programming language, functions are everywhere. Okay, they are just absolutely everywhere. Now, this function happens to take no arguments right here, and it has no name. It doesn't need a name because I just plopped it right in the code here. And this function actually returns something. It returns a text. This text. And you might say, well, where's the return statement? And there really is a return statement right there. It's kind of a hidden return statement right there. And I'm going to leave it in there. If I build and hit Command B to build, by the way, it says build succeeded. That return does belong there. It's just being hidden by Swift just to make the world look a little nicer. And we're going to see a lot of examples of Swift kind of hiding extraneous keywords and things when it's kind of obvious what's going on there. It does that all the time to make our code look a little bit nicer. This is a function with no name, takes no arguments. It returns, in this
It's
case, a text.
dangerous.
So what's it doing there? What is this function plopped right in the middle of the code right after this var body? Well, this var body is not actually stored in memory. It's not a variable stored in memory. It's actually a variable that's calculated by executing this function. Every time someone asks this content view struct, hey, what's the value of your variable called body? It executes this function and returns whatever it returns. In this case, it's going to return this Lego brick, this text. A text, what is a text? A text is another struct that behaves like a view. It's a Lego brick, I said, so it has to be that. In other words, somewhere in SwiftUI, there's something that says struct text. It behaves like a view, and it's probably got var body. It's some view, and inside there, there's some code right there. There's probably some code, something like this, somewhere in Swift, maybe not exactly like that, but something like that. And so this is itself just something that behaves like a view. So you got a function here that returns something that behaves like a view, and that's good because this var body is supposed to be a type that is some kind of view, something that behaves like a view. So these match up. This function is returning something that matches the type of this variable. And of course, if you're going to have the value of a variable be set by plopping a function right in there and have it be executed, then the types better match up. Whatever this returns better match up this. And it does in this case. It's great. In fact, this is going to help us understand what some view really turns into when our compiler is compiling this code. Some view, it's not in of itself a type. It's more like some advice to the compiler saying, hey, this variable's type is going to be some view. Please go figure out what it actually is and replace it with that when you compile it. So in this case, the compiler is going to look at this function, see that it returned a text, and it's going to essentially replace this with text because that is its type. And again, if I compile, succeeds because this var body's type is text. It's got a function that returns a text. So why didn't we just
Or
say var body
compiler.
text in the first place? Why did we do this weird sum view?
You have
There's
some
really two reasons for that.
other
One,
stuff in
if
there.
we're trying to behave like a view, this view
But
thing
the
has to say what you
combiner
have to do
view.
to behave like a view. And so it's not going to say, oh, you got to provide a var body that's a text, because of course you could behave like a view and your var body could be some combination combiner view that's doing this whole UI over here, right? This entire UI in this is returned by the content view of this version of the app. So part of it's just the declaration, just declaring that that's going on. But another part of it is we're going to make this code in here more and more complicated. It starts out as a single Lego brick, ends up being an entire game playing app. And as it gets more and more complicated, the type of the thing that this returns is obviously going to get much more complicated. And we don't want to have to figure out what it is exactly or type it. We want the compiler to figure that out for us. That's what compilers are good at, looking at the code and bringing out what the types of things are. It's very, very good at that. I can show you that very, very vividly by talking about something we already saw, which is padding. So I clicked on my text right here. That has brought back up, and we can resume our preview here, brought back up, it's showing in the preview, and also it brought this inspector back for us. And if you remember, when we originally started this whole thing with this text, we went over here to this padding and we turned it off. It used to be a little blue dot there and we turned it off. I'm going to turn it back on. So it's back on now with all the sides, see padding all right there. So let's talk a little bit about what happened here when we turned this on and off. What
Oh,
is this line of
it's not
code that
text
got
anymore.
kind of plopped in when we turned that back on? This is probably a little more understandable if I move this onto the same line and you look at it like this. First, let me explain that this padding is just a function that exists in all structs that behave like a view. So any struct like content view or like text, anything that behaves like a view, it has a function on it called padding. This is how you call a function in Swift. You just find the struct that you want to call the function on. If you're doing object-oriented programming in Swift, then it's the object, an instance of the class. And you just say dot and the name. Again, hopefully very familiar to you. Java, other languages do this exactly the same way. And then if there are arguments, then you just provide them here. And Swift arguments to functions, you're going to find very, very, very flexible. They can default. You can have different arguments that mean different things. For example, here we have this dot all, and we'll explain what things like that are later, but that means all of these here. And we saw that if I click some of these off, now it's dot horizontal, but it even has other things too. I can type a number here like padding 20. That means put 20 points of padding on every side, or padding 100, put 100 on every side, or no arguments, which means just use default padding, which is a really good one to have because the default padding might be a little different on an Apple Watch versus Apple TV versus macOS versus iPad. So a lot of times we like to use the defaults of things because they're platform specific. But the point is we can put a lot of different things here in the arguments, and it's the same function. Padding does the same thing. It's just that you're providing different information to tell it to do what it does. This function padding returns something. This is really, really important to understand that this padding function returns something. What it returns is something that behaves like a view. Now, it's a different thing than this. Okay, this padding does not return a text. It returns a padded, modified other view, which happens to be a text in this case. The actual type, if I wanted to type it here, I could go try and look it up in the documentation. It's probably something like modified content, something, padding, text, I don't know, something complicated, but it's definitely not text. And in fact, if I put text here and hit build, it says build failed. Cannot convert this expression to type text because this expression is not a text. It's whatever kind of view .padding returns. So it's really important to understand that's what's going on here because we are going to be doing a lot of these kind of little functions that return a new view, a view that's different than another view. They're called view modifiers because they obviously modify some other view. In the Lego world, you can think of it as, well, we took this brick and we sent it back to the factory and said, send us a new one, please, that's padded a little bit around the sides of it. That's essentially what happened, and the factory quickly sent us back a new one, and that is now the brick that we are using here. So it is a modified text. Every time we do a modifier here, it's going to essentially create a new view. And that's why having this be some view, especially as this gets more and more complicated, is really valuable to us. We can see that even more if we add more modifiers, because we can, of course, take these views and modify them again. So let's take our text right here and change its color, for example. So I'm going to have my text selected here, and over in my inspector, I'm just going to change, let's see, the color of the font to orange. It added another modifier here in between that and the padding. Let's see if it worked. It sure did. Now we actually have three views going on here. We've got this original view. We've got the view returned from this function, which is a text modified to have its color be different. And then we have the view that's returned by taking that colored text thing and padding it. And it's this view that is returned as some view right there. So you can see there's a lot of power here by creating exactly the kind of view we want with these modifiers, but really we're only still talking about taking a brick and modifying it. A single Lego brick modified certainly is nice, but we need to be able to combine bricks. When we build something like this card right here, this is a combination of this rounded rectangle and a little emoji string right there on top of it. Combining these and then combining those into this grid and then combining it all into a big app, that's what we want to do. So let's focus here on making just a single card and using a combiner view to combine a rounded rectangle with the text on top of it here, this emoji text on top. So to do that, I'm going to comment out my text here for the moment. So I type command / there. It's a great way to quickly comment things in and out, by the way. And you notice I got all kinds of errors. My preview can't build and all this. That's because I commented out the only thing in this function that returned some kind of view. And so this var body, this function that provides its value, has to return some kind of view. Let's do that. Let's have it return a rounded rectangle. Rounded rectangle, another thing built into SwiftUI. It is a Lego brick. Notice that as you type, Xcode is always jumping in there trying to help you out. Here, it's helping me out with all the different ways that I can create a rounded rectangle. I can do it by specifying the corner radius or even the exact size, the width and height of the corners. And so I want this with corner radius, so I'm going to click here, and sure enough, it filled out some default corner radius here, 25, and there is a rectangle with corner radius. So I'll click away so we can see it. There it is. Look nice, looking good. Looks like a rounded rectangle to me. But a somewhat strange thing happened on the way to creating this rectangle that you haven't seen before. Right, here's my creation of a rectangle. Look at the arguments to create it. Very different than what we had with text or even the function calls we had like color.orange. This argument has a label. And arguments with labels is very common in Swift. It might even be more common than not having argument labels. This text doesn't have something like string because it's kind of like its argument is some text, so it's a little redundant. Same thing here, saying foreground color is color orange. That's the word color too many times. By the way, you don't even need this color because Swift is smart enough to know that you're passing a color, and so you can leave that color out as well. Swift doesn't like you typing the same thing over and over, color, color, color. But here, with rounded rectangle, since I can create one by specifying the corner radius or by specifying the size, if I were just to say rounded rectangle 25, it's just not clear enough what that 25 is. So whenever you define your own functions and the arguments, it's not obvious what an argument would be, you want to define it with a label. And we're going to talk all about functions next week and how we declare them, how we make arguments, how we make them optional, all that business. And one of the things we're going to see is we almost always put a label on our arguments. Really makes the code easy to read. One of the best things that Swift inherited from its predecessor, Objective-C, is these nice labels. And of course, I can change this to anything I want. I can also change it over here in the inspector. We got the rounded rectangle over there. Now, a rounded rectangle is just a view. It behaves like a view. It's a Lego brick. So I could do things like padding. I put some padding on it. Maybe I only want horizontal padding, and it's going to do what I want, make it match up in the inspector. It's all great there. Now, a rounded rectangle is also a shape. I told you that some Lego bricks are shapes, circles and rectangles, rounded rectangles, ovals. They're all shapes. And a shape has one kind of extra thing that it can do, which is that in addition to the shape being filled in like this, you can just outline the shape. And you do that by saying .stroke. So if you put stroke on the end of something that is a shape, then it will just do the outside edge. See the outside, only the outside edge right there, which is what we want it to look like when the card's face up anyway. We want it filled when it's face down and stroked when it's face up. You can also do fill. That fills it in, but this is the default. So that's why we originally had this and it wasn't there at all, right? Stroke is just a function that things that are a shape understand. So I can't stroke a text. It's because a text, while it's a view, is not a shape, so it can't be stroked. But all things that are shapes also are views, and that's why we can pad them. The stroke also can have arguments. They're optional, but like line width 3 makes this line a little bit thicker. Notice this also has a label. So these labels are not just in the creation of structs. They're also when you call functions. Not all of them have it. Padding doesn't use a label. As we saw, foreground color doesn't use a label, but some of them do. So we'll leave that in there just to remind you that can happen. We could also do color. Maybe I want this rounded rectangle to be some color, like maybe the red that we have over here, this red going on. So how do I make it red? Well, I'll just go over to my inspector. Oh no, in my inspector, there's no color. When I inspected a text, it had the color there, and I just picked the orange, and bam, I got this orange text right here. But that doesn't exist here, so what am I going to do? Well, what appears here is kind of like the most common things that people want to put in here, but everything that a view can do is available via this search field right here. See where it says Add Modifier? It's going to let you add any of the modifiers that don't appear here that you want. If I click in here, you'll see that there is an awful lot of
Really
modifiers
feels like
that you know how to do. And we are
Illustrator.
amazingly going
It's
to cover
Adobe
most of these
software.
by the end of the quarter. But right now, it looks kind of daunting. Such a long list. How would you find what you want? Well, you can search in here by just typing, for example, color. This will show you looks like these 7 things that view can be modified to do related to color. Like color invert would invert this, probably turn this from black to white. But we know that we want this one foreground color. Now, when you select it, it actually did add it then as one of the sections here, foreground color. And we don't want blue. We want it to be, let's say, red. And so now we have the red border that we want there. This is getting a little bit messy over here in that our code is wrapping, and it's like wrapping in the middle of a function call here. This is why you're going to see a lot of times these things put on their own line. So I'm going to put that on its own line, that on its own line, that on its own line. It's very common to do that. So we've gotten really good now at taking a basic Lego brick like the rounded rectangle or a text and modifying it to make it look the way that we want. Right? If we look at these cards, it's just a combination of a rounded rectangle and some text. These emoji are just little text strings. So how do we combine these things? Well, we want to return some kind of view, which is a combiner, a view combiner, like the Lego combiner we were talking about before. And so that's exactly what we're going to do. We're going to return a different kind of view called a Z-stack. I'm going to talk about in a moment here what a Z-stack is all about. Let's get rid of our rounded rectangle. When we try to create a Z-stack, do our little open parentheses, well, Xcode suggests 2 different versions, one which has some alignment argument and then content, and another one that is just the content. So we'll talk about this alignment in a second, but the key argument to a Z-stack is content, this content right here. So let's type this content argument. This is the label of this argument. And what kind of thing is it? Well, it turns out to be a function. Yes, functional programming strikes again. This is a function, and this function is actually going to return a bag of Lego. Remember the bag of Lego in our analogy when we're building the Millennium Falcon? That's what we have to give the Z-stack, is this bag of Lego. Swift knows that you're going to want to make these bags of Lego a lot, and so it makes it really easy for you to do. And it's really enhanced the concept of a function to be able to create a bag of Lego. This function, this kind of function that you pass to a Lego combiner view, is called a view builder. And essentially it lets you list other views in here, and then it bags them up into a bag using this function right here and returns it so that the Z stack will have a bag of Lego to work on. So all we need to do is take these things that we've already built down here and just put them in here. We don't need return statements in here. We can just list them. And it's a very strange function like syntax because there's no return statement involved here. This mechanism, this view builder mechanism, knows how to take this list of views and actually combine them into another view, which is a bag of Lego view. Now, the type of that other view, you don't really need to know what it is. It's called tuple view, but you're never going to be.
Or the 11136, like it covers it, so they need this Z stack.
Thing is it? Well, it turns out to be code is wrapping, and it's like and some text. Z stack. I'm going to talk about in a moment here what a Z stack is all about. You can also put if-thens in here. So these bags of Lego can kind of have conditional statements in them. You can even define variables in here. But there's really not much else you can do.
The posture check.
Use if-thens to pick which views you want to have in the bag of Lego.
Welcome
and
back.
Then some, if you need to, do some variables, you can do that as well. Notice that I've been kind of arranging this in the background here. I had the text have its things on separate lines as well, but I used indentation so that when I look in this bag of Lego right here that I'm given to the Z stack, that the leftmost edge is lining up the actual views and the modifiers are indented a little bit. So what is this Z stack thing going to do with this bag of Lego that we passed it? Well, a Z stack stacks these views on top of each other from the device out towards the user. Exactly what we want, right? When we're building this card, there's this kind of background of the card, and then on top of it,
that was flipped.
Nice string right here, which is
bottom.
So it's stacking them towards us. There are other combiners that stack things horizontally, and other ones that stack them vertically, and other ones that stack them in a grid like this.
Z.
So we're just starting with the first one, which is building the cards, but when we want to have multiple cards, we're going to start using some of those other Lego combiners to combine them a different way. You can see it actually already works. Background card, and then here is our hello world. So what we've built here is actually going to be a sum view, which is a Z stack that contains a rounded rectangle and a text. This is not simply Z stack because the type of this Z stack includes the type.
Yeah, anything below 1.5 feels really slow. I used to watch it like 1.75.
Of the things that are included in it. So that doesn't really work to say Z stack. If we let it build, you'll see that it won't allow that to happen. That's again why we need some view. We build this complicated collection of views that are combined with the Z stack. We want to let the compiler figure out the complicated type that's involved here. So we never type the type with some view. We always just let some view get calculated for us. Now I want to talk a little bit about these modifiers that we have on these. Right now we have the modifiers on here, each as we want it. But let's talk about what it means to put a modifier on one of these view combiners. It's really kind of two different categories of things that you want to put on a Z stack. One of them might be padding. So currently we have padding on this rectangle. We also have padding on the text. You can see there's padding around the text. We clearly don't actually need padding around the text. There's no reason to have this padding around the text. So if we take it off and we resume, it doesn't really change the way things work. And we also have padding on the rounded rect, which we kind of want because we don't want it to be over near the edge right here. But we could put this padding on the Z stack itself. So if I take this padding off of here and put it down here, I'm now doing this padding function on this Z stack that I created. And remember, the Z stack is just a view. It behaves like a view. Therefore, it has that function padding. It can be padded as well. And it looks like nothing has changed. By putting that padding out here, everything looks the same. But there is a subtle difference. Watch this. If I click on the rectangle, you see the blue line.
Why did they keep adding dots here? So implicitly modifying the stuff.
Line that defines where the rectangle is, it's no longer padded. So there's no padding on the rectangle. If I click on the Z stack, that's where you can see the padding. The blue line goes all the way to the edge right there. So modifiers, view modifiers like padding work perfectly fine on something like a Z stack. There's no difference really between a Z stack and a rounded rectangle and a text in the sense that they're all just views. So they can all, of course, be padded. But there are other kind of modifiers that are a little interesting when it comes to a view combiner. Let's take, for example, foreground color. Let's take the foreground color off of each of our Lego bricks in here and put it on the Z stack instead. And look what happened over there. I put this on here and everything inside the Z stack turned red. The text turned red and the rectangle is red. So what does it mean to say the foreground color of a combiner is red? The combiner itself doesn't actually draw anything. It combines other things that draw, namely the rectangle and the text. So this kind of modifier gets passed on to all the things inside. Putting foreground color red on the Z stack is exactly the same as putting it here and putting it here separately. This is only, though, the default color, if you put it out here on the Z stack. If I still wanted my text to be orange, I could still say foreground color dot orange, and my text would turn orange. So that is allowed. This is going to be the foreground color of it. This is the default that it's inheriting from its container. And remember, we're eventually going to have containers inside containers as we build these complicated views. And the awesome thing is they'll pass their colors down the chain to each of the levels. So this whole grid of cards is red, we're probably going to set the foreground color red at the very top level at the grid. We're going to set that to be the foreground color of the grid, and all the things inside, including all these cards, are going to inherit that color. And unless they want to override it, they get that color. Before we move along here, I actually want to clean up my code a little bit. Remember, we talked about how Swift doesn't like you to have a lot of extraneous stuff. For example, foreground color, color.orange, we could leave this color off because Swift can figure out what's going on there. And we also know that this return up here, not needed. This is a function. We know it returns some sort of view. The compiler can look in here and see that there's only really this one line of code. This looks like multiple lines of code, but really it's one thing. It's a modified Z stack. It's the only thing that's in this function. So it knows to return this one thing, right? Especially since it matches some view right there. So we don't need that. But there's some other stuff we don't need here as well. This argument to ZStack, right? ZStack only takes one argument. It could take another argument, by the way. Let's put it in here. Alignment, for example, top. That's still stacking these two things on top of each other, the hello world and the rounded rectangle around it, but it's aligning them so they're stuck up at the top instead of the default alignment, which is center. Makes sense. Let's get rid of our orange text, by the way, there too. We want it to all be red. This argument right here, content, its value is a function. It's one of these special view builder functions right here that wraps this up into a bag of Lego, but it's still a function. And anytime you have a creation of a struct or even calling a function and you're passing an argument whose value is a function, then as long as it's one of the last arguments, it can be removed from being inside the parentheses. I have this alignment center, and now I've got this function just kind of hanging out on the edge. It's very similar to this function hanging out on the edge from this body thing right here. We can just leave this like this. Now, why do we do that? Why does Swift allow you to just have this last argument? And you can also do the last couple arguments if they're both functions. Why do we have it hanging out outside of the list of parameters? It's purely for looks. It's purely because it looks nice. And it's even nicer if you don't have another argument, or you're just not going to use that argument. In this case, you can get rid of the parentheses as well. And now you have this beautiful little code here that says, oh, I got a Z stack of these two things. We're always going to do this. No one ever types content : this thing. Okay, we always just leave that off. If we want to put the alignment in there, that's fine. We can go back and put alignment in. But if we're not doing that, we just always do this. A lot of people dive right into SwiftUI and they start with this and they don't really even understand what's going on here. But this is just a function that's an argument to ZStack. It's the content argument to ZStack. And it's a special function because it's a view builder where you can just list views and it packages them up for you. But it's still nothing more than that. Okay, we're going to stick to our pre-pandemic lecture schedule, which is to have 2 80-minute lectures. So I'm going to stop here, and we'll start off next time by continuing this demo and creating multiple cards and making them look a little better, make them scroll around a little bit, adding some buttons, etc.
For more, please visit us at stanford.edu.
Okay. We'll watch another lecture before we jump into the PM. Oh, thanks for watching.